originally, the early geologists believed the Bible, and they took the biblical account of history as being what really happened. And so based on that, they came to the idea that things happened quickly during the creation and the flood. They even developed some geological histories based on that idea.
Later on, at the very turn of the 19th century, you start to get people who are arguing that geological processes from the rock record can only be explained using processes that we see around us today in the world. And so when we see people like Hutton or Lyell who argue for what's now called uniformitarianism, they would look at the geological events that were happening in the world, say how often a river flooded and how much sediment it deposited in its floodplain. They would then say, okay, if there's 1 inch worth of sediment that was deposited this year and next year there's another inch, then when I look at the geological column and I see a rock unit that looks kind of like a flood zone of a river, I should only use the rates that I see today in the modern realm to estimate the amount of time that it took to create that rock. From a myriad of different philosophical and theological reasons, uniformitarianism took over the place of catastrophism, as they argued effectively in many cases that catastrophes, which are not greatly experienced in a day-to-day realm, could not be applied to the geological record. Their arguments, I think, were wrong, but they were effective and they won the day. And it would be over 100 years that a strict view of uniformitarianism, that slow rates and gradual processes, could be the only explanations in geology. It wouldn't be until the middle to late 1900s that we start to see geologists prying themselves from the shackles of uniformitarianism and allowing catastrophes to get a place back in geology. It's not as far as we would like, it's not Noah's flood, but they're starting to recognize that catastrophes do most of the work in geology.
Glacial erosion is usually associated with smooth surfaces and grooves left by the glaciers themselves. But there is another erosional feature which is very interesting, namely what happens to the meltwater that accumulates at the foot of the glaciers. It sometimes bursts as channelized flow, like huge torrents. As they move fast and they carry a lot of sediments with them, they are capable of cutting gaps like this one in this ridge. So this was a continuous ridge which was literally cut by the torrent that came from underneath the glaciers.
In 1980, there was an eruption of Mount St. Helens, and from this single eruption, a pyroclastic flow, that is a flow of hot gas and ash, as it erupted, it left behind some 25 feet, some 8 meters of sediment, which was finely layered, and this was deposited in a very rapid time, less than a day.
From what was learned at Mount St. Helens, we can now understand that there's all sorts of geological processes that can happen in the blink of an eye. From the formation of layered sedimentary units, we can find that there are tens of feet of rock unit that can be formed with fine laminations and thin layerings in between them, be formed in a matter of days. The erosion of small canyons that are like miniature laboratories for understanding how larger canyon systems like the Grand Canyon or the other large canyons of the American Southwest have been formed. Those formed in one case a day, in another case a couple of months. These processes give us a window into understanding the larger scale catastrophes and help us model these larger scale catastrophes when we try and apply our knowledge of geology to Noah's flood. As a geologist, trying to wrap my mind around how much energy Noah's flood actually produced is even hard to do for me. But one thing the creation geologists recognize is that the modern catastrophes that we have, while they give us a tiny glimpse, they really don't come close to the scope and scale of the energy that's being released during the flood. As the fountains of the great deep break open, this means that the Earth itself is being fractured, broken, mashed, and continents are moving vertically, horizontally, moving around with respect to one another. And as a result, tsunami after tsunami after tsunami keeps hitting the continents and driving floodwaters over top of them. The rain is unending. The energy to produce earthquakes and various types of geological catastrophes would be without parallel in the modern world. And so right now we look at the movement of the continents and it's very, very little. But during the flood, we're not talking about continental drift anymore. We're talking about continental sprint, where the continents are moving at rapid paces through the floodwaters and causing all sorts of geological havoc. During the singular event of Noah's flood, catastrophic plate tectonics predicts that the pre-flood ocean crust would be dragged down into the mantle in a process we call subduction. Because that happened very recently, only a few thousands of years ago, the cold ocean crust should still be cold even though it has descended into the deep, hot mantle. Modern seismologists have discovered that there are indeed huge, big, cold slabs of rock down near the core of the Earth itself, in areas that should have warmed up if millions and millions of years worth of time were what has brought those slabs down instead of Noah's flood. The fact that we have cold slabs of rock is a confirmation of flood geology, not of old age geology. Another amazing prediction that has been confirmed in catastrophic plate tectonics is rapid magnetic field reversal. The Earth's magnetic field draws our compass needles towards north, but sometimes in Earth history, it draws it towards the south. Old age geologists believe that magnetic reversals have been happening for hundreds of millions of years and would have taken thousands of years to occur. Ironically, it was actually old Earth geologists working in the Pacific Northwest that found confirming evidence in support of rapid magnetic field reversals that are required for Noah's flood. They were taking a look at lava flows and looking at lava flows that would only take a couple of weeks in order to form. They took measurements of the skin of the lava to see the magnetic orientation. They were expecting to see almost no change as they went deeper into the lava, where the interior should shift only slightly. Instead, what they found is that the outside skin of the lava pointed north and the inside pointed south. So we have confirming evidence from lava flows that the switch of the magnetic field has to happen rapidly, which is exactly what flood geologists expect.
It's amazing to think we can find marine fossils like algae in the very lowest rocks in the geologic column, and marine fossils on top of the highest mountains like Mount Everest. Well, how did they get there? Well, evolutionists would say that slow, gradual uplift over millions of years led to the formation of the mountain ranges and pushed the fossils up along with them.
But there are some things about modern mountain belts that we see that don't seem to fit with this conventional view. Rock is brittle. It doesn't bend very easily. If you try and bend it, it breaks. Now, granted, on a big scale, you might be able to get some pretty big bends out of a large rock. But these bends are tight and close, and you can walk from one end of them to the other. This type of bend and folding without breaking the brittle rock means that maybe it wasn't brittle rock at the time of its formation. These might have been much softer materials. After all, they were laid down during Noah's flood. They've been compacted down, started off horizontal, but then as tectonic movements occurred, they shifted and folded them while they were probably still soft. So when we look at it this way, what we realize is that the really tall mountain chains, the Alps, the Rockies, the Himalayas, they didn't exist before the flood. The whole reason that they exist is because of the flood.
So basically, when we look at the geology of the Earth, we find that present processes do not explain what we see. Rather, what we see points to catastrophic processes in the past, and when we think about what those could be, it fits exactly with the account in Genesis of Noah's flood, which destroyed the whole Earth.
The flood wipes away millions of years from the geological record. Those millions of years are necessary for evolution to occur. No millions of years, no evolution.